lecture, we want to look at the periodic properties of sine, cosine. We're going to start with sine of 30 degrees. And remember, at 30 degrees, we have this point on the unit circle. Why don't you fill that in? Remembering that we are on the unit circle, so that means that r equals 1, and sine is simply y. We see that the sine of 30 degrees is 1/2. The cosine of 30 degrees is √3/2. Now let's think about the sine of 390 degrees. That means we've gone around the circle more than once. In fact, if we start on our initial side at 0 and go 360 degrees, takes us back to the initial side, and then another 30, we end up at the same 30 degrees. So we can say that the sine of 390 degrees is equal to once around the circle plus 30 degrees. And again, it equals 1/2. The same thing is true for cosine. We went all the way around the circle, 360 degrees plus another 30, and is still equal to √3/2. What about 750 degrees? Well, we know that 750 degrees, again, if I start on that initial side, I go once, 360, I go twice, 720, and another 30, back at the same 30 degrees. So we say here that this is 360 degrees times 2 plus 30 degrees. Still equal to 1/2 for sine, and still equal to √3/2 for cosine. Notice that for each of these, going around the circle made no difference to the answer as long as we completed a complete revolution once or twice. We say that sine and cosine are periodic functions. They have a period that repeats every 360 degrees or 2 pi radians. So we say that sine of 30 degrees was equal to the sine of 30 degrees plus once around the circle, plus twice around the circle, plus k times around the circle, where k is any integer. We can say the same thing for cosine. 30 degrees plus once around the circle, plus twice around the circle, plus k times around the circle, where k is any integer. Now, why are we saying that k has to be an integer? Remember, integers are whole numbers, 1, 2, 3, 0, and their opposites, -1, -2, -3. That means there are no fractions of a circle, no parts of a circle. We have to go around the circle in a full revolution every time. Now we can write this formula using radians as well. We can say that sine of π/6 radians, 30 degrees, plus 2 pi once around the circle times k will give us our same answer. It's still equal to the sine of π/6 radians. We can do that for cosine as well. The cosine of π/6 radians plus 2 pi k is equal to the cosine of π/6 radians. We can generalize this formula to include any angle measure. So I have the formulas written here for you, both in degrees. Let's highlight those in yellow. and in radians. What this tells us is that we can ignore the going around the circle, 360 times 1, 360 times 2, 360 times 3. We can ignore this and we're left with the sign of the remainder. The same thing in radians. We can ignore going around the circle and just look at what's left over. This is true for cosine as well, but remember, we say where k equals any integer. K cannot be a fraction of a circle. Can't be part of the way around. So in the next lecture, let's take a look at using this formula.